Today I'll be going over your Unit 4 review in pre-calculus, the no calculator portion. So this first part, we are solving from 0 to 360, so that's going to be on the unit circle, where these trig functions are the specific values. So on the unit circle, sine is our y values, and cosine is our x values. So the first one, we're looking for where y is negative root 3 over 2. So that's going to be down at the bottom of the circle here and here at 240 and at 300. For where sine is negative 1, we're looking for where the y value is negative 1. So that's going to be down at the bottom of the circle at 270. X equals negative root 3 over 2. So now we're looking where our x values are negative root 3 over 2, which is going to be at 150 and at 210. And then where our x values are positive 1/2 is going to be at 60 degrees and down here at 300. For coterminal, we're going to add 2 pi, or 360. So if I add 360, we get 470. If I subtract 360, we get negative 250. If I add 360, we get 240. If we subtract 360, we get a negative 480. For these ones, we're going to add 2 pi, but since it's a fraction, we're going to write 2 pi as a fraction with the same denominator. So 12 pi over 6 makes this 19 pi over 6, 7 pi over 6 minus 12 pi over 6 is a negative 5 pi over 6. And then we'll do the same thing over here. So negative 5 pi over 3 plus 6 pi over 3 is 1 pi over 3. Negative 5 pi over 3 minus 6 pi over 3 is negative 11 pi over 3. Okay, sketch negative 150 and negative 105. So negative 90 would be down here. So negative 105 is going to be about there. The reference angle is the acute angle formed between the x-axis and our angle. So my reference angle is going to be 75. Okay, then we want 4 angles between 0 and 360 with the same reference angle. So essentially we're going to have 1 in each quadrant. So you're going to have 1 with 75 here, 1 with 75 here, 1 with 75 here, and 1 with 75 here. So this first one is just 75. This one is going to be 180 minus 75, so 105. This one's going to be 180 plus 75, so 225. And then this one is going to be 360 minus 75, or 285. Next, we're going to use the unit circle to find the 6 trig functions at these 3 different angles. So on the unit circle, sine is y, cosine is x, tangent is y over x, and then the reciprocals are the reciprocals. So for 150, we find our coordinates are negative root 3 over 2, 1/2. Okay, and from that we get all of our information. So our sine value is 1/2, which means cosecant is 2. Our x value, or cosine value, is negative root 3 over 2. So this is going to be negative 2 root 3 over 3. And then tangent is the y value over the x value, which is going to be negative root 3 over 3 when rationalized. The reciprocal of that is negative root 3. negative 180 is actually the same as positive 180 because 180 goes this direction, negative 180 is here. So our coordinate is negative 1, 0. Okay, so my y value is 0, my x value is negative 1. Tangent then is the y value over the x value, which is 0. The reciprocals though, the reciprocal of 0 is undefined. Reciprocal of negative 1 is negative 1, and this one is also undefined. For 7 pi over 4, in the fourth quadrant, our coordinates are negative root 2 over 2 and negative root 2 over 2. So sine is negative root 2 over 2. If you do the reciprocal of it, it's actually negative root 2. Cosine's negative, sorry, this is positive. Positive root 2 over 2. Positive root 2. Tangent is the y value over the x value, which is going to be negative 1, which means cotangent is negative 1. Okay, so given sine of theta is negative 5/13 and tangent is less than 0, we're going to find the other trig functions. So sine is negative, tangent is negative, so that's going to happen in the fourth quadrant. So that means cosine is positive. So I'm going to go ahead and assign sine and tangent are negative. Sine we know is 5 over 13, so cosecant is going to be 13 over 5. For the rest of these, I'm going to draw a triangle. Okay, sine is opposite, so if theta's here, opposite would be 5, hypotenuse would be 13. Then, using the Pythagorean theorem, I can find the third side. Okay, so we get that x equals 12, or just recognize that Pythagorean triple. From that, we can get the other trig functions. Cosine is adjacent over hypotenuse, so 12 over 13. Secant's the reciprocal, 13 over 12. Tangent is opposite over adjacent, so 5 over 12, which makes cotangent 12 over 5. Next, we are going to graph. On our graphs, you need to do one cycle and have our 5 distinct points. So amplitude is that value 2. Period is 2 pi over b, which in this case is 3. This one does not have a phase shift or a vertical shift. So for the amplitude, I'm just going to go up 2, down 2. For my period, I'm going to go out here at 2 pi over 3. Cut that in half is pi over 3. Cut that in half is pi over 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6, which is pi over 2. Then we'll graph our 5 points. This is a sine, so it starts at the midline, goes to the maximum, to the midline, to the minimum, to the midline. Okay, the next one, my amplitude is 4. My period is 2 pi over 2, so that'll be pi. My phase shift is going to be negative pi over 2 over 2. It's negative c over b. So that's going to be negative pi over 4. So my amplitude is 4, and there's no phase shift. Vertical shift. Go out here with my pi, cut it in half, cut it in half again. Okay, and then a phase shift of negative pi over 4. So if this is positive pi over 4, this is negative pi over 4. Okay, so I have everything I need. We're graphing a positive cosine. So positive cosine starts at the maximum, but we have a phase shift, so it's going to start here. Then it'll cycle through our 5 points. Our next one, the amplitude is 5. The period is 2 pi over 1/3, which is going to be 6 pi. My phase shift is negative c over b, which is going to be negative 3 pi over 2 when you copy, dot, flip, or multiply by the reciprocal. Vertical shift of negative 1. Okay, so for my y-axis, we have a vertical shift of negative 1, and we're going 5 above that and 5 below that. So there's negative 6, there's negative 1, there's 4. So my midline is this. My maximum is at 4, and my minimum is at negative 6. Okay, for my period, this is going to be 6 pi. Cut that in half is 3 pi. 3 pi over 2, 6 pi over 2, 9 pi over 2. And then we have a phase shift of negative 3 pi over 2. So we have all of that set up. We're going to graph a negative sine with a phase shift of negative 3 over 2. So sine starts at the midline, which in this case is going to be shifted back. Then it goes down because it's a negative sine, then to the midline, then to the maximum, then to the midline. Okay, one more graphing. Okay, amplitude is 4. Period is 2 pi divided by 2/3, which is going to be 3 pi. Our phase shift is negative pi over 2/3, which will make that a positive 3 pi over 2. Vertical shift is negative 2. So vertical shift of negative 2 with an amplitude of 4. So we're going midlines at negative 2, 4 below that's negative 6, 4 above that is positive 2. Midline, maximum, minimum. Okay, for my, I have a phase shift of positive pi over 3, or pi over 2. So I'm going to show you 2 ways we can do this. I'm going to put 3 pi here and divide that into 4, because that's our period. 4. So 3 pi over 4, 6 pi over 4, 9 pi over 4. And then I have a phase shift that's going to move it to the right. So I'm going to go ahead and extend. That would be 12 pi over 4, 15 pi over 4, 18 pi over 4, 9 pi over 2. All right, so option 1 is to use the extended. So I'm going to start my graph. This is a positive cosine starting at 3 pi over 2. And then I can cycle through my 5 points with my extended axis. Alternatively, you could start your graph here, go through your points, and then backtrack. So if you had the red graph, that's fine. If you have this blue graph, that's fine. This thing is infinite, so as long as you have one cycle, we're good. Okay, we're going to write an equation for sine with no phase shift. Our amplitude is 3, which means A is 3. My period is pi, which means my B is 2 pi over pi, which is going to be 2. So this will be y equals negative, because it goes down first, 3 sine 2x, or 2 theta. This one, we're going to write an equation with an amplitude of 20, period of 2, phase shift of 4, and a vertical shift of 3. So I need to get A, B, C, and either D or K, whatever you want to call that. A and K are the easy ones. A is going to be 20. K is going to be negative 3. these two require calculations. B is going to be 2 pi over 2, which is going to be pi. My phase shift of 4 is going to equal negative c over b that we just found was pi. So multiply over negative pi to get negative 4 pi. And then put all these together. So we'll put all that together. This is a cosine. So 20 cosine pi x minus 4 pi minus 3. All right, same thing here. We have our amplitude is 2. K, there is no vertical shift, so that's going to be 0. My period is 2 pi over 3, so B is going to be 2 pi divided by 2 pi over 3, which would be 2 pi times 3 over 2 pi, which is 3. My phase shift of negative pi equals negative c over b. So when I multiply that over, c is going to be 3 pi. And then this one wants us to reflect it in the midline, which means make it negative. So y equals negative 2 cosine 3x plus 3 pi, and there's no vertical shift. So we're going to compare sine negative 1x, sine of x to the negative 1, and sine of x to the negative 1. So these look very similar, but they are not the same. So the first one is notation for the inverse. So this is going to be equal to the arc sine x, which is our inverse. Sine to the negative 1, if it's on the outside, that is going to be the power. So that is going to be 1 over sine of x, which is equal to cosecant of x, or the reciprocal. Okay, sine of x to the negative 1 is the same as sine of 1 over x. So these three things are very different equations. In this bottom section, we are using the inverse trig functions. So we developed some unit circles to allow us to work with the specific ranges of those three functions. So for the test, you get a blank unit circle. So you'll fill in the front side with all of your regular trig functions, because we need those for if you're evaluating sine, cosine, or tangent. For the inverses, though, okay, here's how I would do this. You don't have to fill out everything. Okay, we don't need everything on these ones. These ones are simply doing the inverse function. So for sine, I labeled from negative pi over 2 up to pi over 2. There's only going to be radians in the test, so you don't have to do the degrees. And then I only filled in the y value. So the y value here is 1 going on down to negative 1. So when I'm doing the sine inverse, I can just find the one I want and then go over to the appropriate angle. Cosine is from 0 to pi. And then I filled in the x values going from negative 1 to 1. And then for tangent is the same as sine, where it goes from negative pi over 2 to pi over 2. And then my tangent values is y over x. So it's 0 here, 1/2 over root 3 over 2 is root 3 over 3. This is 1, root 3. It's undefined at the top of the circle, and then reflected down. So those are the values that you're going to want on your unit circle, and then we can use that to evaluate. So sine inverse of 1, we're going to the function. You're finding the 1 value where our y is 1, which is going to be at pi over 2. Okay, arc cosine root 2 over 2, we go to this one. We find where x is root 2 over 2, which is at pi over 4. Okay, arc tan negative 1. Go to our last graph, find negative 1, and go to the angle, which is negative pi over 4. Okay, this one, when you're evaluating just the regular trig functions, you want the, this is an inverse. So the inverse tangent of root 3 over 3 is here, which is going to be pi over 6. Then if we turn back around and take the tangent, it's just root 3 over 3. Okay, arc cosine root 3 over 2. So we're going to go to our cosine, find where x is root 3 over 2, which is at pi over 6. Multiply that by 2 is pi over 3. And then we want the sine of pi over 3. So that we would use our regular unit circle. So our y value at pi over 3 is root 3 over 2. Okay, this one, cosine 3 pi over 4 is negative root 2 over 2. The sine inverse of negative root 2 over 2 is going to be negative pi over 4. Okay, sine of 11 pi over 6 is negative 1/2. Our cosine negative 1/2 is 2 pi over 3. Okay, and then our last problem here, cosine inverse 1/2 is going to be pi over 3. So this would be 2 pi over 6 minus pi over 6 is pi over 6. The sine of pi over 6 is 1/2. So this is the no calculator part of your unit 4 review.